Today we are going to solve exponential equations. We have done this a little bit already, but we are going to add on to it today. It says, this is the review piece of it, solve by writing each side of the equation to the same base. And actually we've done this before very recently now. I'm going to skip the first one, leave that for you guys. For the second one here, what we have to do is come up with the same base. And you look at your smaller number and you ask yourself, can you do 8 to a certain power to get to 32? The answer is no. 8 squared, 64, you're already too high. So what you do is you pick a smaller number than 8. Maybe you pick 4. And you ask yourself, can you do 4 to a certain power to get to 8? The answer is no. 4 squared, 16. So drop it even smaller. 2. Can you do 2 to a certain power to get to 8? The answer is yes. It'll be 2 to the third power times x. And then can you do 2 to another power to get to 32? The answer is yes, 2 to the fifth. Now that you have the same base, you set your exponents equal and solve for x by dividing by 3. So you'll get x equals 5/3. For the next one, when you have a fraction, what you're going to do is first flip the fraction. And when you flip the fraction, you got to remember to negate the power. Then you look at your smaller base. Can you do 3 to a certain power to get to 9? The answer is yes. 3 squared will give you 9 times the power that's up there already. Now that your bases are equal, set your exponents equal. So x will equal -2. Okay, we're going to use a new method here. Sometimes you can't find a common base. It's not possible. So what we're going to do is another way. Now, just to prove to you that the other way will give you the same answer, let's look at the first one together. Even though I could come up with a common base. The other way to do it is to write it using logarithms. You could take the logarithm of both sides. When you take the logarithm of the left-hand side, it becomes x log 2. When you take the logarithm of the right-hand side, it becomes log 8. And then to solve for x, what you would do is you have to divide by log 2. Well, log 8 divided by log 2 is 3. The next one, when your base is an e, what you're going to do instead of using taking a logarithm to both sides, you're going to take a natural logarithm. So it's going to be a ln e. What you do to one side, you do to the other, so ln 254. To solve for a here, we divide by ln e. Remember, ln e is also just a 1, so dividing by 1 would just give me ln 254, which if I'm rounding, it's going to be about 5.54 in your calculator. This next one, what we have to do first is divide by 7 to get the exponent piece by itself. So 2 to the b equals 815/7. Then we take the logarithm of both sides, so it's going to become b log 2 equals log 815/7. To solve for b, we divide by log 2. When you type that in your calculator, you get about 6.86. Couple application problems, and now on the Regents exam, they will have to give you the formulas I'm about to give you. If $100 invested receives 5% interest each year, how many years will it take the interest to have doubled in value? The formula they have to give you is y equals p times 1 plus r over n to the nt. P stands for the principal. R stands for the rate. N stands for number of times compounded yearly. And T stands for time. Okay, so they're investing $100, that's the principal. We want it to double, so the Y, that's the ending amount, is going to be 200 equals 100 for the principal times 1 plus my rate, 5%, as a decimal it's 0.05, And it's compounded annually, so that means once a year, so over 1 to the 1t power. We're looking for how much time, so 1t. To solve this equation, what we'll do is divide by 100 to start, and you'll get 2 equals. Inside parentheses, if I simplify that, that's 1.05 to the t power. Notice it is the t that we are solving for, so we'll take the logarithm of both sides. It'll become log 2 equals t log 1.05. And to solve for t, we divide by log 1.05. And when you type that in your calculator, you get 14.2 years. The next one, an element has to decay that much per day. After how many days will 7 grams remain from a 10-gram sample? Okay, so this is the formula, and again, they had to give you a formula. A sub n will equal A sub 0, e to the RT. AN is the amount at the end. A0 is the initial amount. R is the rate. T is time. So the amount at the end is 7. The initial amount is 10. E is that button in your calculator. The rate is 0.00866 t. To solve here, we're first going to divide by 10. So we'll have e to the negative 0.00866 t equals 7/10. Now, instead of taking the logarithm of both sides, we're going to take the natural logarithm of both sides. So it's going to be negative 0.00866 t ln e equals ln of 7/10. You know ln e is just a 1, so I usually just cross it off at that point. To solve for t, I'm going to divide by negative 0.00866. And then when you type that in your calculator, you will get t is equal to about 41.2 days. At this point, I think I only skipped one problem for you guys to do. Yeah, just try that first problem at the beginning of our notes. And we will work on more on this tomorrow.